Okay, so today we're talking about lesson 2.4, and that's 3.4 in our textbook. So if you want to refer to that, you are welcome to. I think the deal is that we're looking to have bring together the vocab so far. And so these first couple questions, if you read through them, you'll notice they're pieces that we've already talked about. So the first one says the process of observing data, recognizing patterns, making generalizations from observations is called what? And that would be inductive, okay? Inductive reasoning. The second one says, in mathematics, a generalization made using inductive reasoning is called a conjecture. Okay, you'll want to study your vocab for your quiz tomorrow. So conjecture. The third one says a blank is needed to show that a conjecture is false. Well, that's a counterexample. Okay, so a counterexample. So if you make a conjecture like, oh, I noticed that everybody itself is really nice. Well, that's a conjecture, and you can maybe disprove it if you found an example that causes that not to be true. Okay, the next part. And what kind of statement can be written as an if-then statement and consists of a hypothesis and a conclusion? Again, we'll talk about this as well. What contains a hypothesis and conclusion? That would be a conditional statement. Okay, so a conditional statement. So remember, the hypothesis does not include the word if. So people who blah, 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 and then as a result, the then part is not part of the result, the conclusion. So the if is not part of the hypothesis, the then word is not part of the conclusion. The hypothesis follows the word if, and the result follows the word then. That's a conclusion. Okay, the process of what kind of reasoning uses facts, rules, definitions, or properties to take a hypothesis and reach a specific logical valid conclusion. That would be deductive. Okay, a blank is one way to take a conditional statement, an if, and then link the hypothesis. Okay, so a conditional statement, if-then statement, and link the hypothesis to a conclusion in a step-by-step manner. Using statements and reasons that are accepted as true. That's a proof. Okay, that's what we're going to be talking about today. How can you show that an if-then statement is true? How can you do that? Okay, and so you can prove a hypothesis to a conclusion by using a proof. Now, when you're making a proof, you can use conditional statements if-then that are accepted true. So we're allowed to use things that are absolutely true within our proof, and those are called postulates. Okay, so postulates would be like, hey, if you have a line, it's comprised of at least 2 points. Okay, if you have two planes, okay, they intersect at a line. Okay, just those basic things that you don't have to prove to use, but you're allowed to use them, and they're true without proof. Okay, and then after a statement, it has been proven true, it is called a theorem. And you can use those as well in your proofs, and you're allowed to prove them, but you're also to say people can prove them. And so we're going to be using deductive reasoning to make proofs moving forward. Okay, so here are some must-know postulates. These are things that are accepted true, and they're if-then type statements, but they're good to say, hey, but I understand how I could use them. All right, so here we go. A line postulate. What's that mean? Well, a line contains at least 2 points, okay? Through any 2 points, you can draw just exactly one line. So to go through any 2 points, there's only exactly one line that you can draw, okay? If you want to draw a different one, it'd have to have a curve in it. So between any 2 points is just one line, exactly one line. The plane postulate. A plane contains at least 3 non-collinear points. If you've got 3 non-collinear points, you will have a plane. Okay. Now, planes are comprised of infinitely many points. However, 3 non-collinear points can define one lane or one plane, exactly one plane. The flat plane postulate. Okay, so think about your desk. Okay, if you draw 2 points on your desk, okay, and you connect them, every point on that line will be on that plane. Okay, like how would that not be the case? Well, if we believed in curved planes, like a sphere, then maybe they would not contain all the points on the line. Okay, think about a ball. If you try to balance a stick on a ball, okay, not every point on that stick would come in contact with a ball. And so, and of course, people do geometry on spheres because we live on, an Earth, which is round. Okay, but the thing is that we're going to be saying if you have a flat surface and you have 2 points on that surface, then that entire line will be on it as well. All right, so the flat plane postulate states that if 2 points lie on a plane, then the entire line that contains them is also on the plane. So because planes are flat, it would contain all these pieces. And the contrast to that would be like, okay, so the contrast to that would be like if we had like the world and we put like a stick on that, like a line on the world, the whole line would not coincide with the world, would it? Okay, so we're talking about, assume we have a flat plane, not a round, like curved surface that we're placing our shapes on. So we are taking a flat surface, we're placing a line on it. Every point on that line is going to be on that flat plane. Intersecting lines. When you have two lines that intersect, how will they intersect? If they intersect, they're going to intersect at one point, exactly, not two. If they're parallel, no, they won't intersect, but intersecting lines intersect in one point. Intersecting planes, if two planes intersect, they will intersect at a line. Here we go, okay? And unless they don't, which means that they're parallel. Okay, the midpoint theorem and the definition of a midpoint. So the midpoint theorem states that if you have a segment that is broken up by a midpoint, then the two segments are congruent to each other. So that would be the midpoint theorem. But the definition of a midpoint would talk about the equality of the lengths of each of those sides. So if you're talking about the measurement of each of those legs or those segments, then we would talk about the definition of a midpoint. And then congruence. If two things are congruent, then they have the same shape and size. Okay, and so the congruency theorem says that if two shapes are congruent, they have equal shape and size. My favorite is going to be the definition of congruence, which is if you've got something that is equal, then it's going to be congruent, or backwards. If it's congruent, it's going to be equal. So if two segments are congruent, then by the definition of congruence, you can say their lengths are equal. Okay, and vice versa. If you can go, hey, the segments are equal, then they're going to be congruent. So that's a really helpful thing to link together the concept of equality of length or measurement, and then also the congruency of the shape. And so that's a good thing. So when we go through these examples, it's like, okay, if you've got line R and you've got line N, they intersect at D. Well, what would be the point of that? That's going to be the intersecting lines postulate, okay? And you can't read that because I wrote with a highlighter, but I'll say it out loud. Intersecting lines postulate, okay? Intersecting, and it's still with a highlighter. That's really not going to help you. The intersecting lines postulate. Okay, so the intersecting lines postulate. It's on the front. Plane P contains, and where's plane P? Plane P is on this side over here. Okay, plane P contains these 3 points. Well, what postulate talks about the points contained within the plane? Well, that would be the plane postulate. Okay, the plane postulate. Okay, and then planes P and Q. Okay, P is on the side, Q is this front plane. Where do they intersect? Well, at the line AD. What one talks about that, I'll tell you verbally because my handwriting is terrible, is the intersecting planes postulate. Okay, so the intersecting planes postulate. And then are these always, sometimes, or never true? Does line R, okay, so if this is line R, does it only contain point P? And the answer is never. Why? Because of the line postulate. Okay, so the line postulate says every line contains at least 2 points, if not infinitely many. So no, it won't just have 1 point. It may have just 1 point labeled, but it has at least 2 points to make a line. Through points H and K, there's exactly one line. Yeah, as long as you're going straight, absolutely, which is what a line does. That's always as well. And so through any 2 points, there's only one line you can draw. So again, that's a line postulate as well. If two coplanar lines intersect, okay, two coplanar lines intersect, then their point of intersection is on that plane. Well, look at this. If you see two lines intersecting on a flat plane, their point of intersection is also going to be on the plane. So that's always, and that's going to be the flat plane postulate. So as long as the two lines are on there, then every point in common, as well as every point on each line, will be on there. So it's that is called the flat planes postulate. 4 points are non-collinear, and the answer is They might be and they may not be. Okay. And so any 2 points are collinear. So, but 4 points, we don't know that sometimes. Okay. And that has to do with lines, it has to do with planes. But that is not going to be, that's going to be sometimes they're collinear and sometimes not collinear. The intersection of 2 planes is a point? No, that's never. Why? Because 2 planes always intersect as a line. Okay, so that is going to be the case. When we talk about proofs, we want to talk about, we're going to be making a diagram and label our known information. We're going to be taking our given information, and that's going to be the if, okay, or the hypothesis. Okay, so they're going to say, if you have a triangle, okay, cool. They're going to give us information about it. And then they say, here's where I want you to get. I want you to prove that this triangle has 2 sides that are congruent or something like that. And how do you get from what they give you, the if, to the conclusion, which is the proof? Well, what you do is you've got to do some statements, and then you do some reasons to say, well, if you have a triangle, then 3 sides are, it has 3 sides. Why? By the definition of a triangle. Okay, if you have, a triangle, then you have 3 angles. Why? And so you're going to talk about statements and say, can I start with my given, and can I walk through to the result, okay, the proof. And so here are 2 little proofs, and I'm not going to ask you to do homework proofs in your homework, but it says Q is the midpoint of PR. So if you've got this, Q is the midpoint of PR. Okay, cool. And that's given. Okay, you always start with the given and say, hey, you gave me that. So you start with what you're given. And you say, okay, then what can I say? Well, if it's the midpoint, you know that PQ is equal to QR. That lengths are congruent. Why? And if you look at your original thing, it says that's a definition of a midpoint. Okay, because if you look at the previous page, the congruent one has to do with the theorem. Okay, the definition one has to do with the lengths being equal. And then the last part says, well, if you know their lengths are equal, how can you say that they're congruent? Well, that is going to be the definition of congruence. Okay, this is right here. If things are equal in length, then they are going to be congruent, and vice versa. And so down here, we're going to say, how come if these are equal, then they're congruent? It's because the definition of congruence. Okay, so that is the truth there. The last one, it says, hey, look at this. B is the midpoint of AC. Cool. Okay. And then C is the midpoint of the segment as well. Okay. And then it tells you that these 2 segments are congruent. We'll get back to that in a minute. So the first thing is that you have 2 different midpoints, and that's given. As a result, AB equals, okay, BC, that length, those are congruent. And we also have DC is equal to CE. Okay, so why? Definition of midpoint breaks it up into equal size. And then another given fact they gave us was that AB equals CD. So AB equals CD. Wait, CE. Okay, cute. So we're going to use substitution. Look at this. It says our next statement is going to be BC equals CE. BC equals CE. Okay, so if you notice this, AB has been substituted with BC. How can you do that? Well, look at this. AB equals BC. So therefore, when you see AB, you're allowed to put BC in its place, and that is substitution. Okay, you're substituting something equal for it in its place. And then to get from BC equals CD down to here, notice you are taking, let's see, BC is the same, CE becomes DE. Well, look at this. CE and DC are the same, so you can do substitution again. So those are some principles we'll work into. We're not there. I just wanted you to say, hey, this is a proof. We start with a given, we end up with a result, and how do we get there? Well, we talk about logical things that we know.